Hello everybody, you're very welcome to this episode of Programming and Algorithms. In this episode we're going to look at sorting, and in particular sorting data in an array. So if we remember our integer array from before, we said the data in it is unsorted, that is to say it's not in any particular order, whereas when we're talking about sorting the data, what we want to do is get it in ascending order, that is to say smallest to largest number, left to right. So as a human being, it'd be easy to do that particular array just by inspection, whereas if the array was 100,000 elements long, it would be much more difficult for a human being to sort it. So we need to develop algorithms or recipes to do the sorting. And the simplest and most common algorithm that people learn first is called Bubblesort. Bubblesort works as follows. For an array of size n, we just look at the first two elements and we check if the first element is bigger than the second. If the first element is bigger than the second, we swap it. If it's not, we don't do anything. Then we look at the second and third, then the third and fourth, the fourth and fifth, and we check if the left element is bigger than the right in each case. If the left is bigger than the right, then we swap them. If they're in the right order already, the two elements, then we don't do anything. We keep on doing that until we get to the end of the array. That doesn't mean the array is sorted though, so we jump back to the start again and do that whole process again and again and again until the array is sorted. Let's think about the swapping bit for a second. If I want to swap two values, the following approach will not work. If I have the first element and I assign the value from the second element to it, and then I assign the value from the first element to the second element, that won't work. Because if we think about it, if we say that the first element's value is 44 and the second is 23, if I say the first element now gets the value of the second one, so if the second is 23, the first is now 23, that means they're both 23 now. So then if I try and say that the first element gets the value of the second, or the second gets the first, they're all 23. So we've lost the number 44 completely, so that swap doesn't work in that way. What we need is an extra variable to make this work. Let's call it temporary value, and that temporary value will store one of the values so that the swap will work. So let's say we give temp value the value of the second element, and then we say that the second element is overwritten by the first element's value, and then the first element gets the value of temp value, then the swap will work. Let's imagine our values again. 23 is stored in temp value, 44 is written into the second element, and then 23 is written into the first element. So then we have a successful swap where first element is now 23 and the second is now 44. So if we want to see the if statement that goes around this for Bubblesort, for the first two elements, it's if the second element is less than the first element, then we do the swap. So if the second is less than the first, do the swap. And there's no else needed, because we do nothing if they're in the correct order already. We could generalize that to if n minus 1 is less than the value in n, or even index plus 1 bigger than index. And in all of these cases, if the element on the left is bigger than the element on the right, we swap, otherwise we don't. If we want to go from the start to the end of the array in pairs, we note that the array goes from 0 to n minus 1. So the loop goes from 0 to n minus 2, because that'll compare 0 to 1, 1 to 2, 2 to 3, so on up to n minus 3 to n minus 2, and then n minus 2 to n minus 1. So it'll compare all the elements to each other, because index will go and compare n minus 1 to n minus 2. That's index to index plus 1. So that doesn't mean the array is sorted just because we do that once though. One pass doesn't get it done. Here's an example. We start off, we compare the first two elements. Is the left element bigger than the right? Yes it is, so we swap. We look at the next two elements. Is the left bigger than the right? Yes it is, so we swap. Do it again. Is the left bigger than the right? Yes it is, so we swap. We do it again. Is the left bigger than the right? Yes it is, so we swap. We do it again. Is the left bigger than the right? No, it's not, so we don't do anything. We check the next pair. Is the left bigger than the right? Yes, it is, so we swap. And finally, is the left bigger than the right? Yes, it is, so we swap. So now we have not sorted the array, but we have pushed the largest value, 54, to its correct position, because it's at the top of the array now. So if we do that again, 23 and 42 are in the correct position, so we don't do anything. 42 and 33 swap. 42 and 16 swap. 42 and 44 don't do anything. 44 and 34 swap. 44 and 18 swap. And 44 and 54 are fine. So what happened there? We've pushed the second largest value, 44, into its correct position. Next time around, compare those two, no swap. Compare those two, swap. Compare the next two, no swap. Compare the next two, and we swap. Compare the next two, and we swap. And everything else is as is. So we've pushed the third largest value the next pass around the array we've done. Let's try it again. 23 and 16 we swap. 23 and 33 no swap. 33 and 34 no swap. 18 and 34 we do swap. 34 and 42 no swap. 42 and 44 no swap. And 44 and 54 no swap. So we've pushed 34 into its correct position. Let's do it again. 16, 23 no swap. 23, 33 no swap. 18, 33 we swap. And then the rest there's no swaps. So we've pushed 33 into the correct position. If we do it again, 16, 23 no swap. 23, 18 swap. 23, 33 no swap. No swap. No swap. No swap. And no swap. So now we have moved the sixth largest value, 23, into its correct position. Let's not bother doing it again though, because the array is sorted now. So 16, 18, 23, 33, 34, 42, 44, and 54 is all sorted now. So we need one loop that is going from the start to the end of the array, and then an outer loop around that which says keep doing that n times. So from 0 to n minus 1. So go from start to the end of the array and go back to the start again and do it again, and do it again, and do it again, and do it again, and keep doing it until the array is sorted. And that is what Bubblesort looks like. So our pseudocode program Bubblesort declared the integer with two loops, a for loop, that's the outer one that goes from 0 to n minus 1, and then the inner one, which is 0 to n minus 2. If the inner index, if the value on the right is smaller than the value on the left, swap them round, otherwise do nothing. Keep doing it and you'll have your array sorted. Here's a visualization of it. It gets sorted from the top all the way down. So that's it. Thanks very much. We'll see you on the next episode.